Welcome to the Interstellar Age. Season 2, Not Alone. Episode 5, Dawn of an Age, 2082 to 2104. The Singapore conferences in early September 2082 were only a first, and very tentative, step towards a lasting relationship between humans and virgonids. While the affability and charming, if slightly uncanny, humanity of the arthropoid aliens served to put most Terrans at ease, not everyone was convinced. Many still felt as the Langworth coup plotters had, that the aliens would inevitably become a threat, whether they intended to or not. In that case, humanity needed to defend itself, preemptively if necessary. Many others were ecstatic, seeing first contact as the beginning of a new era of peace and prosperity. But most remained wary, waiting to see how this great and frightening new moment would unfold, which way the wheel of history would turn. Indeed, this was a historic moment, perhaps the most momentous in human history, one of which billions had long dreamed, the moment we learned for certain that we were not alone in the universe. For all the physiological and cultural differences between the two species, diplomatic relations proved surprisingly easy to establish. This was thanks in large part to more than a century of virgonid observation and study of humanity, as well as their preternatural ability to learn and adapt. The virgonids had no demands and conversed fluently in any human language, using dynamic speech synthesis and translation devices they invented during their mission in Seoul. These form the basis of the translation protocols and systems still in use by the Compact and a number of independent powers today. The Peacemaker had been in regular contact with its homeworld throughout its mission, but the 22-year time delay for round-trip messages meant that the Greater Hive had little influence over the mission from day to day, or even year to year. Still, George and his comrades had no compunctions about conducting agreements with humanity as if they spoke for their entire species, even after dozens of generations spent physically apart. The Singapore conferences quickly reached a preliminary agreement, establishing a framework for future cooperation between the GDA and the virgonids in Seoul, in the areas of scientific research and cultural exchange. At the conclusion of the conferences, a joint message was sent back to Ross 128, recommending that a treaty between the two worlds should be signed, but it would be another 22 years before a reply could be received, and even longer before a formal delegation could be sent by the Greater Hive. In the meantime, as part of the initial Singapore agreement, the virgonids offered to provide whatever assistance they could to help humanity recover from the Third World War. Within days, virgonid teams were at work repairing infrastructure, assisting with land reclamation and radiation cleanup. Within 2 weeks, noticeable progress had been made. Within 2 months, irradiated areas of Eastern Europe, China, and northern India, which had been projected to be uninhabitable for decades, were once again livable. The virgonids openly shared the designs for the technologies they used to achieve these feats, further dispelling the concerns of many skeptics around the world. Though the more conspiracy-minded would never fully accept the virgonids' peaceful intentions, and some of these fringe groups even question their motives today, more than 400 years after first contact. The only thing the virgonids did not yet share was their propulsion technology, specifically their ability to manipulate the mass of objects, making them far easier to accelerate and decelerate. This was the technology that had allowed Peacemaker to reach average velocities near 0.6 c in its 20-year journey from Ross 128 to Seoul, and which gave their reconnaissance craft the extreme speed and maneuverability that had confounded human observers in the 20th and 21st centuries. The virgonids freely admitted that they were reluctant to share this technology out of concern that we would turn it into a weapon. The peace since the end of the Third World War had been a fragile one, never more so than during the First Contact crisis, which had come hours or even minutes away from plunging Earth into an interstellar war. The unity which the resolution of that crisis had inaugurated might prove just as fragile. If the GDA shattered and the world plunged once again into war, immature and powerful mass manipulation technology might make it unsurvivable. But the importance of the technology for space exploration meant that humanity would not simply forget about it. If we could not get it from the virgonids, we would pursue it on our own. The virgonids, for their part, were well aware of this, and they promised to share the technology and the science behind it, if they could fully participate in a slow and deliberate research and development process to ensure it was not misused. Negotiations on this point continued throughout 2082 and early 2083, with the Peacemaker, now orbiting Luna, serving as the official virgonid embassy in the Sol system. A formal treaty was finally signed in August 2083, 1 year to the day after Peacemaker rescued the Destiny crew. The leaders of the GDA Security Council, Secretary General Levesque, and astronauts Galloway and Novikova were all present for the historic moment. The Treaty of Luna established formal relations between Earth and the virgonids then in Sol, with the trade and communications provisions already agreed to, plus a plan to establish joint human virgonid research facilities on Mars and Luna. Now that the deal had been signed, the virgonids hoped a new human perspective might help them take their mass manipulation technology to the next level. The lunar and Martian bases would have as their goal the development of a practical means of faster-than-light travel. The virgonids' mass manipulation technology functioned by generating a field of what humans called the Higgs anti-boson, a particle that repels the Higgs boson, which is itself the particle that imparts mass to other particles. The Higgs exclusion field that these particles create effectively neutralizes the mass of objects contained within it. This allows said objects, including ships, to accelerate exponentially faster and with exponentially less energy input. While the speed of light limit still applies to these objects, Higgs exclusion allowed virgonid ships to accelerate up to 0.99 c, although considerations such as energy usage and collisions with interstellar dust particles limit the practical maximum velocity of most ships to around 0.6 to 0.7 c. A more advanced version of this original virgonid technology remains in use throughout the compact to this day, since it can operate on a sliding scale within the gravitic threshold of stellar bodies and other large masses. But while high subluminal velocities had enabled the virgonids to reach Earth and several other nearby stars, the speed limitation meant that the bubble of practical interstellar travel remained small. Thanks to time dilation, a virgonid generation ship could theoretically travel hundreds of light-years, provided enough fuel and supplies. But it would take thousands of years from an outside reference frame to get to its destination, and then hundreds more for a signal to get back. This might be good enough for an ultra-long-term colonization project, but it was not so practical for space exploration, diplomacy, and trade. Virgonid scientists had determined that the missing ingredient was gravity, a problem that they, despite their scientific skill and thousands of years of study, had still not been able to solve. It was a problem that had bedeviled human physicists for decades as well. But the virgonids hoped that our seemingly preternatural ability to leapfrog basic steps in the scientific method in times of crisis and opportunity, combined with their millennia of accumulated knowledge, would finally crack the problem. If gravity could be solved, and that knowledge extrapolated into workable technology, then a ship might be able to travel faster than light, at least in a relative sense. If that barrier could be broken, the whole galaxy might one day be opened up to human and virgonid exploration and colonization. After a preliminary exchange of materials and concepts, the Joint Research Commission made the decision to split into 2 projects, each based on a parallel theoretical path. Headquartered at the Artemis base on Luna, Project Enterprise, named after a spacecraft from a popular science fiction series from which some of the principles were derived, would focus on developing a so-called warp drive based on Alcubierre-White-Stephen theoretical principles, a combination of theories developed in parallel on Earth and Virgon over the preceding centuries. The warp drive would function by creating a large positive mass in front of a craft to create an area of contracted space-time. Simultaneously, a negative mass would be generated behind the craft, creating a zone of expanded space-time. The craft would then, essentially, surf on a wave of warped space-time. Technically, the craft would be stationary relative to its local space. Only the wave would be traveling faster than light, and as a zone of space-time, it would not really be traveling at all, allowing the ship to skirt the laws of physics rather than breaking them. Creating a positive mass was already achievable with virgonid mass manipulation technology. To create the much more elusive negative mass, Project Enterprise would focus on developing a source of negative energy, a force or material with an energy density less than zero. The effect of such a force on spacetime would be to bend it in a manner opposite to positive mass and energy. At the time, no such energy existed. While previous human theories had suggested that massive quantities of negative energy would be required to make the warp drive work, virgonid mass manipulation tech drastically reduced the energy requirements. If a substance capable of generating negative energy could be created, there was no theoretical reason the warp drive should not work exactly as conceived. Project Star Drive, based at a new and growing facility on Mars, intended to iterate on existing virgonid technology. The project leaders, Dr. Chandra Vaughn and the virgonid known as Carl, theorized that if a craft's mass could be completely neutralized, and it could be isolated from the effects of gravity, it could be accelerated not just up to, but beyond the speed of light, using conventional engine technology. In theory, this might at first seem to be the easier path. However, the problems of gravity and the universal speed limit of c remained. But Carl and Dr. Vaughn were confident that they were close to proving a quantum theory of gravity, one which included a graviton particle, and which would prove many of our fundamental assumptions about spacetime wrong. Furthermore, their theories implied that a version of the old Einstein ether modifications of special relativity were in fact close to correct, and that there is a preferred foliation of spacetime, a universal ether field at which spacetime is directionally agnostic but temporally ordered, and at which c no longer applies as a universal speed limit. This concept would later be referred to as the Vaughn-Carl metaframe, or simply the metaframe. In theory, a craft with its mass completely neutralized could sidestep inertial resistance. Then, if it could also be shielded from gravitons, it would be able to sidestep the curvature of spacetime itself. This would allow it to decouple from the base frame that normal matter inhabits and couple itself to the metaframe with its enforced universal time direction. Once coupled to this preferred foliation, a ship could be accelerated up to and beyond c without violating causality. It would travel in FTL in a linear physical direction while always traveling in the same temporal direction, forwards. Of course, there were a great many ifs in that formulation, and just as many places where the entire framework could fall apart. As a result, Project Enterprise was initially heavily favored to succeed, garnering the lion's share of available resources. And indeed, Enterprise made some promising early progress, particularly in the field of ghost condensates. A ghost condensate is a metastable field based on an exotic ghost particle that creates negative energy when disturbed. Virgonid scientists had been creating unstable ghost condensates in laboratory conditions for decades, but had never been able to stabilize one. If one could be stabilized, it would be able to provide the negative mass region necessary to create the aft portion of a warp bubble at relatively low energy and mass requirements. After just 2 years of work, Enterprise scientists announced in late 2087 that they had created their first stable ghost condensate. Soon they would scale up to drive-level experiments using existing theoretical frameworks. It seemed that FTL and the stars might already be within reach after only 5 years of human-virgonid cooperation. But early excitement soon turned to disaster. In July 2088, a massive explosion obliterated the entire Project Enterprise research facility on Luna. The blast blinded sensors and jammed communications all across the Earth, fried every satellite in lunar orbit, disrupted comms as far away as Mars, and killed all 106 human and 57 virgonid researchers in the facility. It also blasted a 3-kilometer-wide crater in the lunar surface, and remains to this day the largest man-made explosion in solar history. Initially, no one knew what had happened. Panic spread through the solar system. Stories quickly propagated that the mysterious UACs, which had not been seen since the First Contact crisis, had been spotted above the facility in the weeks, days, even hours before the blast, meaning this could have been alien sabotage, or even a prelude to invasion. But the rapidly spreading evidence supporting this claim was soon shown to have been fabricated. The facility had been recording everything moment to moment and storing the data both on-site and on Earth. Investigators from Peacemaker and the GDA Space Agency soon discovered the truth. The ghost condensate Enterprise scientists created had not actually been stabilized. It was most likely metastable, but in so minute a way that the sensors of the day had not been capable of detecting it. At the time of the explosion, researchers had been conducting a drive-level energy experiment, disturbing the condensate to create negative energy-generating ripples. Earlier tests at smaller scales had been successful, but at this higher energy level, the ripples caused the testing condensate to suffer a catastrophic vacuum collapse. This in turn detonated all the other unstable material in the facility, generating an apocalyptic blast that wiped out the entire base. A deeper investigation showed something even more terrifying. There is a hypothesis, which to this day remains untestable, that the Higgs field, which imparts mass to particles, is not stable, but metastable. Given the fact that the ghost condensate was composed in part of Higgs antibosons, there was a non-zero chance that the vacuum collapse of the condensate, under the right conditions, might have triggered a cosmic false vacuum collapse in the Higgs field. Such an event would have created a bubble of collapsing Higgs field, expanding at near the speed of light. Everything within the bubble would have ceased to exist, instantly decohering at the subatomic level. This bubble of dead universe would have swallowed the entire inhabited solar system in under an hour, then continued expanding outward indefinitely. No force known to science would have been able to stop it or even slow it down. The only thing that would have prevented the bubble from consuming the entire universe would have been the universe itself expanding at the same speed of the bubble, keeping everything beyond the cosmological horizon forever out of reach. The odds of such a doomsday scenario occurring were incredibly small, and contingent upon the metastability of the Higgs field, which most physicists believe to in fact be stable. Still, even the smallest chance that the technology might destroy the entire observable universe, to say nothing of the more mundane destruction it in fact wrought, led to the immediate and indefinite shuttering of Project Enterprise. Project Stardrive was also put on hold while a thorough review was conducted, to make certain that none of their research might lead to a similar catastrophe. Vaughn, Carl, and the rest of their team continued to work on their theory while they waited. By the time Stardrive was reauthorized in early 2089, they believed they were close to a breakthrough. Nearly a year later, in February 2090, they announced that they had finally discovered the elusive graviton. This long-sought particle was the missing piece, which enabled the Stardrive team to complete their quantum theory of gravity, which, in turn, they believed would unlock the potential of faster-than-light travel. But they still had to prove it. With the massive influx of funds and resources that followed the monumental discovery, new experiments came thick and fast. Virgonid anti-boson generators proved easy to adapt to generate antigravitons, not true antiparticles, but graviton quasi-particles engineered to locally cancel spacetime curvature by repelling standard gravitons. This enabled further experiments, in particular efforts to decouple particles from the base frame. In 2092, the first macro-scale object, a coffee mug, was successfully decoupled. Later that year, the same cup was successfully recoupled to the metaframe. In 2093, larger objects were recoupled and accelerated to high subluminal velocities on the Martian test range. Space tests followed, but then progress stalled, as even in deep space, objects proved impossible to accelerate beyond 0.9 c. Previous models suggested that superluminal acceleration should have been trivial once metaframe coupling was achieved, suggesting that either the models were wrong or existing technology was insufficient to the task. Further study through 2094 showed that baseframe decoupling was not, and likely could not be, perfect. Any decoupled object still experienced a minuscule amount of bleed-through into standard spacetime, which meant that a metaframe-coupled object was still subject to enough Lorentz invariance to prevent superluminal travel. Then, in early 2095, another breakthrough was achieved. Up to that point, in the interest of efficiency, researchers had been using relatively low levels of drive energy to accelerate mass-neutralized metaframe-coupled objects. But after a malfunction on the power regulator of a test engine showed surprising results, Dr. Carl, by then the third virgonid scientist to bear that name, devised a modification to the existing framework. In addition to the high energy requirements to decouple and recouple an object, extremely high levels of drive energy might be enough to break local Lorentz symmetry and permit superluminal acceleration. The amount of energy required would scale with the physical size of the object, since larger objects occupy more spacetime and have a proportionately higher frame drag. Wedding the existing star drive prototype with a higher efficiency fusion reactor rolled out that same year by a joint human virgonid design team finally produced a workable result. On May 20th, 2095, a test engine called Firebird achieved 1C+ for 30 seconds. The test was met with jubilation throughout the solar system. A long road remained ahead before manned interstellar travel would be possible, but this test, finally, showed that it was possible. Indeed, it was now all but inevitable. Just 3 years later, the first manned test flight was launched, traveling from Mars to Earth in 4 minutes. In 2100, a manned test flight left the solar system and returned. Then, in 2103, the Peacemaker, retrofitted with a new star drive, returned home. Carrying a human delegation from Earth, including Destiny astronauts Galloway and Novikova, Peacemaker arrived at Virgon in September 2103, after a journey of just 5 months. After a tour of the hives, Peacemaker returned to Earth once again, this time carrying an official delegation from the Greater Hive. The ship arrived in March 2104, 3 months ahead of the virgonid reply to the first signal sent from Earth in 2082. That signal's arrival in June 2104 marked the occasion for the signing of a formal political and economic treaty between the GDA and the Greater Hive, the first of its kind in known galactic history. The treaty was signed on Mars, near the Project Stardrive research facility, itself near the planned landing site of the original Destiny mission. The Treaty of Mars thus recognized both the disaster and the breakthrough that ultimately brought the two species together. To this day, the human-virgonid relationship remains the closest in the galaxy. Indeed, the virgonids recognize humanity as a part of their greater hive, in effect, as members of the virgonid species. But in 2104, all of that was still in the future. For now, it was enough for humanity to know that the long, painful, and anxious post-war era was finally over. A new age was dawning, an age in which the human race would be united as never before. With their new friends from another world, they would soon reach out for the stars, for the unknown, and for new hope. But whether that unity would survive the cold vastness of interstellar space was another question entirely.